Okay, so today from class we went over the notes, and some of the highlights were these two details. And something that would be important to make sure that you're studying would be this chart right here. When you see these units, any of these units, or you read any of these values, you should be able to realize what symbol we're talking about and which of these two formulae we're using, and sometimes you'll have to use both depending on what you're doing. Other parts of this that are kind of important to understand is in grade 9 and 10 you may have also talked about or discussed how these two formulas can be rearranged, or how you can rearrange them easily. So for example, if you had this, you could remake it into that triangle. Or if you had this formula over here, you could rearrange it into there's your triangle there. And you'll remember that if you cover up, so let's say I cover up capital N equals N times NA, or Avogadro's number. And then over here, if I didn't know, lowercase n equals lowercase m divided by capital M. I'll go over a couple examples here. So let's look at a couple examples. So to begin with, how many particles are in 0.84 moles of water? So what I do when I look at this question is I see certain values, and when I see this, this jumps out at me right here. So let's go back to some grasp problem solving from grade 9 and 10. So I know that my given here is I've got 0.84. And when I think about that, I hope that you kind of think, well, what is that? So go to the chart from earlier on, and you know that lowercase n represents moles. You've got 0.84 mole. So the next thing I do is I read the question, and I see that I need to figure out how many particles. So I look at my two formulas and I think which one of these two formulas deals with particles, and it's important to think when you look at this and to think back to your chart. Well, what is particles? And particles would be represented by N. So which one of these deals with capital N? Let's see here. We've got capital N over here, so I'm going to be using this. So we've got N already figured out. And then next we know NA. So I then know that NA equals 6.02 times 10 to the power of 23. We're going to need to have some units on that. So when we talk about NA, NA's units are particles per mole. So that's particles per mole. And then in this question, well, what are we required to figure out? Well, we need to figure out what capital N is. So we do not know in this question what capital N equals. And in grasp problem solving, you had to figure out last year, A was, figure out what you need to do next. So what is the formula for N? So I look up here, and I can even think in my head and think of your triangle. And so what are you covering up? Well, if you have the triangle N, N, and NA, and there's your triangle there, when I cover up over top of N, I know that it's N, lowercase n times Avogadro's number, or moles times Avogadro's number. So then I would write in that capital N equals small n times Avogadro's number. And then solve, well, I would then say equals 0.84. I'm just running out of room here. I'll see if I can get myself a bit more room here. There we go. So 0.84 mole times 6.02 times 10 to the 23 particles per mole, and you'll notice that your moles cancel out, leaving you with only particles left over. Just give me a second to grab my calculator. And so I get as an answer 5.0568 times 10 to the power of 23 particles. But then I have to look at significant digits. So I look back at the start of the question, and I see that in my question at the start, my original number had 2 significant digits. So I now must round this to have 2 significant digits. So the answer would be 5.1 times 10 to the power of 23 particles of water. So here we've got 0.84 moles again, so N is still 0.84. But what's important here is to look at what we're being asked, and in the question you're being asked what is the mass. So when I see something like this, I think in my head and I think, what of my 2 formulas do I have uses mass? Both of them use math. So I can think that M and capital M, if I'm looking at this here, I've got little n, I'm going to try to figure out M, and I can figure out capital M. So to figure out capital M, I use a periodic table, and I know that capital M equals 2 hydrogens, so 2 times 1.01 grams per mole. Sorry, I forgot my moles right there. Plus 16.00 grams per mole. Write in your units throughout, don't make them appear from nowhere. And that's going to equal 18.02 grams per mole. Hopefully in your head you're now thinking, what do I need to figure out? And you're right, we don't know what lowercase m equals. So let's go ahead and we'll do the math. I'm just going to separate off my page a little bit here. So lowercase m equals lowercase n times capital M, or moles times molar mass, which equals 0.84 mole times, and let me move things over just a little bit here, times 18.02 grams per mole. Our moles cancel out, leaving us with just grams left behind. And then finally we do our math of 0.84 times 18.02 equals, so I'm left with 15.14 grams. But now I have to look back at my significant digits from the start of the question, and I see that in the question I stated that 0.84 has 2 significant digits, which means that I must represent the answer I have here with 2 significant digits. So I must now write this with 2 significant digits, which would be, therefore, 0.84 mole is 15 grams. So let's go on to the last example here. When I read the example, there's 2 steps to this. So I'm going to do one step here. There's a second step there. So let's start with the first step. So I see in the question I've got mass of 23.46 grams. Make sure that you're studying so that way you know that when you see mass, you know that grams is mass, and you know the symbol for mass is lowercase m. This is going to be something that you must know. How many moles? So when I think of that, or when I see that question, I know that I need to find little n, and I've got lowercase m, which formula uses little m and lowercase n, this one right over here. So that's the one I'm going to be using. I now go and I write down capital M, and I know from before or earlier work Now my molar mass is 18.02 grams per mole, and usually you would do that work, but for now that's okay. Now we need to figure out lowercase n because we don't know what that is. I think of that triangle again in my head, and I know that lowercase n equals lowercase m over capital M, or mass over molar mass, or mass divided by molar mass, which becomes 23.46 grams divided by 18.02 grams per mole. My grams and grams cancel out, leaving me with 1 over mole, which is also moles. And that's going to equal 23.46 divided by 18.02 equals 1.301 moles. So that's my lowercase n. But the question doesn't stop there. The question goes on to ask how many molecules of water are there in this mass. So this is n right here, and if I figured out moles, now I've got to figure out, well, if I've got Avogadro's number, which is 6.02 times 10 to the power of 23 particles or molecules per mole, then what I can say is, well, we've got n equals 1.301 moles times 6.02 times 10 to the power of 23 molecules per mole. I'm going to run out of room here on the side. I wonder if I can keep pushing this over. Nope, I can't. So that's molecules per mole. And what ends up happening is my moles cancel out. So that cancels out, that cancels out. And when I do my math, I would say 1.301 times 6.02 times 10 to the power of 23 equals, so I'm going to make sure I write this with 4 significant digits as per the class rule, so 7.832 times 10 to the power of 23. Now I have to go back to the start and look. Okay, so I start out with 1, 2, 3, 4 significant digits, and I've got 1, 2, 3, 4 significant digits. The only thing I've forgotten here is I forgot my units, and I'm measuring here is molecules. Good luck with the homework.